Welcome to mathematics class, matrices part 7. In the last class, we have discussed about determinants, which is also a very important concept. And we did some problems based on that concept determinants. So in continuation, let us practice some more problems from the exercise 3D. These are long questions. Roman exercise 3D, Roman 2, the first bit. Show that the determinant value is equal to a minus b, b minus c, c minus a. So this is the determinant. bc, b plus c, 1, ca, c plus a, 1, ab, a plus b, 1. So let us take this determinant and find the right side value. This is left side, LHS. So in the next step, we have to show a minus b, b minus c, c minus a. Now let us use transformations. So we are going to change the R1, the first row, R2, second row. So second row we are changing R2 minus R1. These are the transformations, R2 minus R1. And we are writing first row as it is. BC, no change in first row transformations. And I am changing second row as R2 minus R1. So this is R2 minus R1. I am subtracting R1 from R2. So CA minus BC. And the second element also R2 minus R1, C plus A minus B plus C. C plus A minus B plus C. So minus into plus minus B minus C. This is second. And this one, 1 minus 1. So now let us write this. So the second one, BC, B plus C, and this is 1. And next transformation, R3 also, we are changing R3 as R3 minus R1. So we are subtracting R1 from R3. So this is R3 minus R1, R3 minus R1. So R3 minus R1. So AB minus BC. AB minus BC. This is R3 minus R1. A plus B minus B plus C, that is minus B minus C. minus B minus C and 1 minus 1 third element. So we are subtracting R3 elements. We are subtracting R3 minus R1 and R2 minus R1. So these two changes. R2 we are changing second row as R2 minus R1 and third row as R3 minus R1. ఇవి రెండు మార్పులు మనం పైనుంచి కిందికి చేస్తున్నాం. R2 రెండో అడ్డు వరుసను మార్చినాము, మూడో అడ్డు వరుసను మార్చాము. So now further simplifying. So first I am writing first row as it is, no change in first row. So in second row, CA minus BC, taking C common, so this becomes A minus B and plus C minus C will get cancelled. Plus C minus C will get cancelled and this will remain A minus B. So 1 minus 1 is 0. So in third also, taking B common, taking B common. So this is A minus C. So here plus B minus B will get cancelled. A minus C in second column. So 1 minus 1, 0. So after simplifying, this becomes this. So from R2, A minus B, 0 can be written as 0 into A minus B. So A minus B is a factor in all the elements of all three elements of second row. So A minus B, you can take A minus B with 0. 0 into A minus B is 0. So you can imagine 0 as 0 into A minus B. Similarly, in third row also 0 into A minus C. So A minus B from second row, taking common. So now taking A minus B from R2 and A minus C from R3 as common. So taking common A minus B from R2 and A minus C from R3. ఈ A minus B రెండవ వరుస నుంచి అదే విధంగా A minus C మూడవ వరుస నుంచి మనం కామన్ బయటికి రాస్తే సో A minus B from R2 and A minus C from R3 we are taking common. So the first row no change. First row will be same. No change in first row. And in second row we are taking A minus B common and what will remain? In first element C, after taking A minus B, C will remain. In second element, after taking A minus B, 1 will remain and 0 will remain as 0. So from third row, after taking A minus C, B will remain and A minus C, 1 will remain, 0 as 0 only. So after taking A minus B, A minus C common from R2 and R3, we get this one. Now let us expand, find the determinant by using the definition along with the C1. Determinant can be calculated taking any row or taking any column. So already in the last class, what is determinant explained. The sum of the product of any row or any column, product of element and its cofactor. The sum of the product of elements with their cofactors is called determinant. మూలకము దాని సహ గుణావయవాల లబ్ధాల మొత్తం, ఏదైనా ఒక అడ్డు వరుస కానీ నిలువు వరుసలో కానీ, అది దాని నిర్ధారకం అవుతుంది. సో ఇప్పుడు ఐఎమ్ టేకింగ్ C1, 1 into its cofactors A minus B. I'm writing this as it is, and into, now finding the determinant of this. So 1 into, after leaving the row and column, we are taking the remaining 4 elements. సో డిటర్మినెంట్ ఎలా అనుకుంటాం, ఈ 1 ఉన్నటువంటి రో అండ్ కాలమ్ను ఎలిమినేట్ చేస్తే ద రిమైనింగ్ 4 ఎలిమెంట్స్ని తీసుకుంటాం. సో దిస్ ఈస్ ద కోఫాక్టర్ 1. సో నెక్స్ట్ second element, third element of C1, 0, 0, I am expanding. So along with C1, third column, C3. So 0 into anything is 0. We need not take the other 4 cofactors. So that is the advantage of zeros. That's why we are taking the determinant along with C3. The remaining 2 elements 0, only we need to take consider 1 into this 4. మిగతావి జీరోలు కాబట్టి వాటి వాల్యూ ఎనీహౌ ఇట్ ఈస్ గోయింగ్ టు బికమ్ 0. సో ద డిటర్మినెంట్ ఈజ్ ఓన్లీ 1 into this 4 2/2 determinant. So further simplifying, this is A minus B and A minus C. So here the determinant of 2/2 is just like cross multiplication AB, AD minus BC. So C into 1 C minus 1 into B B, C minus B. So all this other becomes 0. So we take only C minus B. A minus B, A minus C, C minus B. So these 2 multiplying with these 2, A minus B as it is, and taking A minus C common, minus common, this you can write it as C minus A, and minus 1 common from C minus B, this becomes, you can write it as B minus C. So minus into minus will become plus. So now this is equal to A minus B. I am writing B minus C. Next C minus A. So this is what is required. So this is the required right hand side. So taking LHS, we get RHS. So this is the LHS is equal to RHS. So hence prove. So these are the 7 marks questions, long questions. The determinants using the transformation. In the last class, I explained the loss of determinants. So we are using row transformations to simplify the given determinant so that it will be easy for us to prove the required result. ముందు వీటిని రో ట్రాన్స్ఫర్మేషన్స్ ఉపయోగించి సూక్ష్మీకరించడం వల్ల మనకు కావాల్సినటువంటి దాని సమాధానం సాధన లభిస్తుంది. సో నౌ లెట్ us take another problem from the exercise. These are all long questions, important. Show that B plus C, C plus A, B plus C, C plus A plus B. This is first row. A plus B, B plus C, C plus A plus B, B plus C, and C plus A, second row. ABC, third row. So this is the given matrix, and this should be equal to A cube plus B cube plus C cube minus 3ABC. So we have to show that this determinant is equal to A cube plus B cube plus C cube minus 3ABC. Okay. Now let us take left hand side LHS. B plus C, C plus A plus B. So B plus C, C plus A plus B, given determinant. A plus B, B plus C, C plus A, and A, B, C. So taking LHS, we have to prove the RHS. Now, using transformations, I am changing R1. I am changing the first R1 as R1 plus R3. So R1 plus R3, B plus C plus A, and C plus A plus B. So A plus B plus C. So this is the transformation. So using this transformation, this can be equal to first row becomes B plus C plus A. B plus C plus A, R1 plus R3. And second element also C plus A plus B, and it can be written as A plus B plus C. This also A plus B plus C. So this also you can write it as A plus B plus C. And second, third, you can change second also. The second row also you can change it. R2 minus R3. R2 minus R3. So we are subtracting R2 minus R3. So after subtracting R2 minus R3, A plus B minus A plus B minus A, B plus C minus B, C plus A minus C, and R3 as it is, A, B, C. No change in R3. Only we are changing R1 and R2. ఈ రెండు వరుసలను మాత్రమే మనం మార్చాం. So simplifying this and taking A plus B plus C is there in R3 in all the elements. So taking A plus B plus C as common from R1. So R1 నుండి A plus B plus C కామన్ తీస్తే మనకు A plus B plus C బయట రాస్తున్నాం. So this becomes 1, 1, 1. So from R2, A minus A will get cancelled, B minus B, C minus C will get cancelled. So R2, BCA, BCA, and R3 as it is, A, B, C. No change in R3. So after that, we can simplify or direct calculate the determinant. A plus B plus C. Now let us find the determinant of this in along with R1. మొదటి వరుసను ఉపయోగించి దీని డిటర్మినెంట్ రాద్దాం. So 1 and the 4 numbers. So eliminating the row and column, we get the 4 numbers CA, BC. CA, BC. For second number, you take minus the cofactor, you get minus 1 to the power I plus j. In the last class, all these things explained. And minus 1, take the remaining 4 numbers. We are calculating along with R1. So eliminate CB and take BA, AC. This BA and AC, 4 numbers, and 1 into eliminating AC and take the remaining 4 numbers, BC, AB. So BC, AB, 4 numbers. So leaving the column below that element and take the remaining 4 elements. So this is the procedure how to find the determinant of 3x3 matrix. So this is element and this cofactor. Element and its cofactor. Element and its cofactor. This you remember. The det A is equal to A into A 11 into A 11. This is element and its cofactor. Element into its cofactor. Let us take the cofactor as C11 and second 12 C12 and 13 C13. So this is the definition of determinant. It is the sum of the product of the element and its cofactor of any row or any column. So this is the det A. So మూలకము దాని కోఫాక్టర్, మూలకం కోఫాక్టర్ వీటి లబ్ధాల మొత్తము దాని నిర్ధారకం అవుతుంది. సో simplifying this, AD minus BC, AD minus BC, AD minus BC. So C into C, C square minus AB. So this is minus into BC, A into A minus A square. So this is B into B, B square minus AC or CA. So this is A plus B plus C into C square minus AB minus BC minus into minus plus A square plus B square minus AC. And it can be written as A plus B plus C into A square, B square, C square. I am writing first A square plus B square plus C square minus AB minus BC minus CA. So this is a formula, well-known formula, and its value will be our required answer. So this is A cube plus B cube plus C cube minus 3ABC. So this is our required answer, right hand side. So LHS is equal to RHS, hence it is proved. So remember, this is the formula A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA is equal to A cube plus B cube plus C cube minus 3ABC. It is well-known formula from the algebra. So it is a simple proof, important. Now let us take up one more important question from the exercise. If A square 1 plus A cube, A square 1 plus A cube, B square 1 plus B cube, C square 1 plus C cube. This determinant is equal to 0 and A square 1, B square 1, C square 1. This is not equal to 0. Then show that ఇవి రెండు, ఇది 0 ఇది 0 కాకపోతే, then show that ABC is equal to -1. Very important question. Look at this. Taking the given condition, now A A square 1 plus A cube, B square 1 plus B cube, C square 1 plus C cube. So this is equal to 0. This is the given condition. Now, splitting the left side into two matrices. This is already explained in the properties of determinants. We can split it into two determinants, A square 1, B square 1, C square 1. So A square 1, దీన్ని రెండు మాత్రికలుగా విడగొడుతున్నాం. B square 1, C square 1. This is first determinant plus left side can be written as sum of two determinants, A square A cube, A square A cube, B square B cube, C square C cube is equal to right side 0 as it is. The C3 అనేది 1 plus A cube, 1 plus B cube, 1 plus C cube ఇట్లా సమ్ ఆఫ్ టూ నంబర్స్గా ఉన్నప్పుడు ఆ డిటర్మినెంట్ను రెండు డిటర్మినెంట్స్గా సమ్ ఆఫ్ టూ డిటర్మినెంట్స్గా స్ప్లిట్ చేసి రాసుకోవచ్చు. ఇది డిటర్మినెంట్స్కి ఉన్నటువంటి ఒక ప్రాపర్టీ. Using that property, we are splitting the left side determinant into two determinants, sum of two determinants. So next, the first one as it is, A square 1, B square 1, A square 1, B square 1, C square 1. No change in first. A square 1, B square 1, C square 1. No change. So here A square A cube. I am taking A from R1, B from R2, C from R3. So taking common A, B, C from R1, R2, R3 respectively. So I am taking A from R1. A అనేది R1 నుండి, B అనేది R2 నుండి, C అనేది RT నుండి కామన్ తీస్తే ఇక్కడ 1A A స్క్వేర్ వస్తుంది. 1A A స్క్వేర్, ఇది 1B B స్క్వేర్, ఇది 1C C స్క్వేర్. సో ఏబిసిలు కామన్ తీసిన తర్వాత we get this one. Now ఇంటర్చేంజింగ్, ఇక్కడ మనకు A అనేది ఇక్కడ రావాలి. ఐఎమ్ ఇంటర్చేంజింగ్ C1 as C2 as C1 and C3 as C2. I am interchanging two columns. This one's no change. A square 1, B square 1, C square 1. So here I am interchanging. So I am changing ABC C1. I am interchanging C1 and C2. C1 C2 ఇంటర్చేంజ్ చేస్తే అప్పుడు ఏమవుతుంది, ABC ఫస్ట్ రో అవుతుంది. ఇక్కడ A, B, C. ఇట్లా ఇంటర్చేంజ్ చేయడం వల్ల we get minus sign. Again, I am interchanging C and C2, interchanging C3. ఇక్కడ 1 1 1 ఉంది, అది ఇక్కడ రీప్లేస్ చేస్తే అప్పుడు C2 C3 అవుతుంది, C3 C2 అవుతుంది. ఇది A square B square C square 1 1 1. So we are interchanging the columns. So interchanging the columns or rows, we get minus sign. So 2 times we are interchanging, minus minus will become plus. So further simplifying, and right side is 0. No change in first determinant. A square 1, B square 1, and C square 1. No change in this one. It is A, B, C, minus minus will become plus. And here A square 1, B square 1, C square 1, and is equal to 0. And taking these two common, taking these two determinants as common, we are taking this common. A square 1, B square 1, C square 1. I am taking this determinant as common, and what will remain in first term 1, in second term ABC. So taking the entire determinant common from two terms, we will get this one. So from this we get 1 plus ABC is equal to 0. So here what is there? The product of these two is equal to 0. So ఎప్పుడు ఈ product 0 అవుతుంది? Either one of the factors should become 0. So either this determinant value should be 0, or this 1 plus ABC should become 0. Then only this product will become 0. ఇవి రెండు గుణిస్తే 0 ఎప్పుడు వస్తుంది అంటే ఈ రెండిట్లలో ఏదో ఒకటి 0 కావాలి, అప్పుడే దీని లబ్ధం 0 అవుతుంది. అయితే the first one is not 0, it is given in the question. సో ఈ ఫస్ట్ వన్ 0 కాదు అని క్వశ్చన్లో ఇచ్చిండ్రు కాబట్టి ఇక there is no other way, the second factor should become 0. ఇది 0 కాదు అని క్వశ్చన్లో ఇవ్వబడ్డది, తప్పనిసరి ఈ 1 plus A plus B 0 కావాలి, అప్పుడే దీని వాల్యూ 0 అవుతుంది. Since so this second 1 plus A plus B becomes 0, why this one is not 0? A square 1, B square 1, C square 1. This is not equal to 0. This is given in the question. So since it is given, this is not equal to 0. Therefore, the second one becomes 0. Otherwise, we will not get 0. The product should become 0. Therefore, any one of them, either of them should become 0. As the first one is not 0, is given in the question, then the second should be equal to 0, second factor. So since it is not 0, we get 1 plus A plus B is equal to 0. And taking this right side, we get A plus B plus C. So this gives A plus ABC is equal to -1. ABC is equal to -1. So hence prove. Very important question. Long question. This is also. Now let us take one more question from the text. This is Roman 3rd. The first question. Show that a plus b plus 2c a plus b plus 2c and a and b. This is first. Second row, c b plus c plus 2a b plus c plus 2a and b. Third row, c a and c plus a plus 2b c plus a plus 2b. So this is the given determinant, and the value is 2 into a plus b plus c whole cube. We have to show this one. Now let us prove taking LHS and taking the transformations. This is C1, C2, C3. I am changing column transformations here. So I am changing C1 as C1 plus C2 plus C3. Columns transform చేస్తున్నాం. సో ఇప్పుడు ఇవి a plus b plus 2c plus a plus b plus a 2a plus 2b అవుతుంది. ఫస్ట్ కాలమ్ 2a plus 2b plus 2c and you can write it as 2 into a plus b plus c. 2a 2b 2c లో 2 కామన్ తీస్తే అవుతుంది. నెక్స్ట్ సెకండ్ c plus b plus c plus 2a plus b. ఇవి 3 ప్లస్ చేస్తే ఇవి c plus c 2c అవుతుంది, b plus b 2b. Again this also becomes 2a 2b 2c కాబట్టి 2 కామన్ తీస్తే this is also become 2 into a plus b plus c. Similarly the third యాడ్ చేస్తే c plus a plus c plus a plus 2b. ఇది కూడా సేమ్ 2 into a plus b plus c అవుతుంది. The remaining you can write as it is. Remaining C2 is a, this is b plus c plus 2a, so b c plus a plus 2b. ఇక్కడ C1 ఒకదాన్ని మార్చినాము. C1 C1 plus C2 plus C3 మూడు కలిపి C1 గా రాసుకున్నాం. కాలమ్ ట్రాన్స్ఫర్మేషన్. ఇందులో నుంచి టేకింగ్ కామన్. నౌ టేకింగ్ కామన్ 2 into a plus b plus c from C1. మొదటి నిలువు వరుస నుంచి దీన్ని కామన్ తీస్తే సో 2 into A plus B plus C remaining C ఇది 1 1 1 అవుతుంది. ఇది A B plus C plus 2A A B B C plus A plus 2B. Now ఈ 1 1 1 వీటిని మనం further simplify చేస్తే, so this can be further simplifying. I am writing this as it is 2 into A plus B plus C. I am writing the first row as it is 1A B. So R2, I am changing R2 as R2 minus R1. R2 minus R1. I am changing R2 as R2 minus R1. So R2 minus R1, 1 minus 1, 0. So the B plus C plus 2A minus A, 2A minus A is A. So this becomes A plus B plus C. B minus B becomes 0. Next, R3 also I am changing R3. So R3 also I am changing R3. So R3 minus R1. R3 లో నుండి R1 తీసేసి దీన్ని కూడా మనం మార్చి రాస్తున్నాం. R3 minus R1. R3 minus R1. So R3 minus R1. So what do you get? 1 minus 1, 0. A minus A, 0. C plus A plus 2B minus B. 2B minus B becomes B. That is C plus A plus B. C plus A plus B. That is A plus B plus C. Now, two into A plus B plus C. So finding the determinant. So 1 into the remaining 4 numbers. The remaining 4 numbers, 1 into remaining A plus B plus C, 0, 0. This is also A plus B plus C. So the remaining 2 elements zeros, 0 into anything will become 0. So only the determinant we take this first one, 1 into its cofactor. The other 2 already becomes zeros. So we need not take them. Further simplifying, A plus B plus C. So the cross multiplication AD minus BC, we know. The 2 by 2 matrix determinant AD minus BC. So A plus B plus C into A plus B plus C. So this is A plus B plus C whole square. This is AD minus BC, that is 0 into 0 is 0. So this can be further simplified. A plus B plus C into A plus B plus C whole square. So that is 2 into A plus B plus C whole cube. So this is the required answer. So therefore, left hand side is equal to right hand side, hence proved. So this is also important question from the text. So now let us take another question, another important question. Show that these are all long questions. Show that ABC, BCA, CAB square is equal to 2BC minus A square, 2BC minus A square, C square, B square, C square, 2AC minus B square, and A square, B square, A square, 2AB minus C square. So this one is equal to A cube plus B cube plus C cube minus 3ABC minus 3ABC whole square. So we have to prove this one. So it is also, so this is also very important question. So we have to prove. So this is equal to this is equal to this. Two equalities. Now let us consider the determinant ABC, BCA, CAB. Consider ABC, BCA, CAB. Now let us find this value. And find the determinant. So it's determinant A into the remaining 4 elements, eliminating after neglecting the row and column CAAB. CAAB minus B. So the remaining leaving CA and take the remaining 4 elements A into BC వదిలిపెట్టి CAAB minus B. ఈ సెకండ్ ఎలిమెంట్ కు మైనస్ వస్తుంది ఎందుకంటే దీని కోఫాక్టర్ మైనస్ అవుతుంది కాబట్టి దీనికి మైనస్ వస్తుంది. రిమెంబర్ the second element the cofactor will get minus sign, so that's why we are taking minus. And the remaining 4 BCAB, remaining 4 BCAB, and third element C into దాని కింద ఉన్న 2 వదిలిపెట్టి మిగతా 4 ఎలిమెంట్స్ తీసుకోవాలి. So leave this 2 elements and take the remaining 4 BCCA. So ఇది determinant తీసుకునేది. A into its cofactor, B into its cofactor, C into its cofactor. So A into A కింద ఉన్న 2 వదిలిపెట్టి మిగతా 4, B into B కింది 2 వదిలిపెట్టి మిగతా 4, C into C కింద ఉన్న 2 ఎలిమెంట్స్ వదిలిపెట్టి మిగతా 4 తీసుకుంటే మనకు డిటర్మినెంట్ వస్తుంది. సో ఇది డెఫినేషన్. డెట్ ఏ అంటే ఆల్రెడీ ఇంతకుముందు రాసుకున్నాం. ఏ ఇంటూ A11 C11 A12 C12 A13 C13 element and its cofactor. సో ఇక్కడ ABCD డిటర్మినెంట్ ఏమవుతుంది? AD మైనస్ BC, జస్ట్ క్రాస్ మల్టిప్లికేషన్. సో ఇది BC మైనస్ A స్క్వేర్, BC మైనస్ A స్క్వేర్. ఇది B స్క్వేర్ మైనస్ AC, క్రాస్ మల్టిప్లికేషన్ అనుకోండి జస్ట్. సో ఇది B ఇంటూ A, AB మైనస్ C స్క్వేర్ అవుతుంది. సింప్లిఫైయింగ్ ఫర్దర్, A ఇంటూ BC ABC, A into A square A cube, B into B square B cube, minus minus will become plus, B into AC ABC, ఇది ABC minus C into C square C cube. So ABC 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 3ABC minus A cube minus B cube minus C cube. Taking minus common, this can be written as A cube plus B cube plus C cube minus 3ABC అని రాయొచ్చు. మైనస్ కామన్ తీస్తే అన్నిటి గుర్తులు మారుతాయి. You can take minus common and remaining will change its sign. So now squaring. So squaring, we want the square of this value. ABC, BCA, CAB. So this value is minus of A cube, B cube, C cube minus 3ABC. Now I want square of this one, squaring both sides, square of this one. So minus square will become plus. So minus square will become plus. So therefore ABC, BCA, CAB, the determinant square is equal to A cube plus B cube plus C cube minus 3ABC square, whole square. So this is the first proof. We have proved the first one. First one is equal to A cube plus B cube plus C cube minus 3ABC. We have to prove one more. So now let us take the same thing. ABC, BCA, CAB square. So square is A square is equal to A into A. So similarly ABC, BCA, CAB into ABC, BCA, CAB. So A square is equal to A into A, as A square is equal to A into A. So the square is equal to 2 times. So now we are changing R2, R3, interchanging. interchanging these two rows. So in right side, so in RHS, we are interchanging R2 and R3. So what do you get? The sign which it changes its sign, -1. So this one is same, ABC, BCA, CAB, and ABC as it is. So now let us write -1 here, -1. So R1 is same, ABC. So in place of R2 BCA, I am writing R3, that is CAB, and R2 as R3. ఇది పైకి వస్తుంది, ఇది కిందకి వస్తుంది. BCA కిందకి వస్తుంది. ఈ R2 R3ని ఇంటర్చేంజ్ చేసింది. BCA కింద వస్తుంది, CAB పైన. R2 ప్లేస్లో R3, R3 ప్లేస్లో R3. సో ఇట్లా ఇంటర్చేంజ్ చేయడం వల్ల ఏమవుతుంది? మైనస్ సైన్. సో if you interchange any rows or columns, the determinant value will become minus. So now I am multiplying this minus with R1. Multiplying this minus, I am multiplying -1 with R1. ఈ R1 లో ఉన్న ఎలిమెంట్స్ ని మైనస్ తో ఇంటూ చేస్తాం. I am taking inside this minus ABC, BCA, CAB. This is same. So this becomes -A, -B, -C, and remaining same, CAB and BCA. So now let us multiply. Multiplication of matrices, we know rows into columns. So rows R1, R2, R3, C1, C2, C3, rows into columns. So rows into columns. So first matrix rows we multiply with columns of the second matrix. This is the procedure of multiplication, we know. Now let us multiply R1, C1. This is R1, C1, R1, C2, R1, C3. This is first row. Next R2, C1, R2, C2, R2, C3. Next R3, C1, R3, C2, R3, C3. So this is the procedure of multiplication. So we multiply the same R1 with C1, A into A. So what do you get? A into A minus A square, B into C, BC, C into B, CB or BC. So this is R1 or C1. Next R1, C2, A into B minus AB, B into A plus AB, C into C, C square. Next R1 with C3, A into C minus AC, B into B plus B square, C into A, that is CA or AC. So you can see here plus AB minus AB will get cancelled, minus AC plus AC will get cancelled. So this is BC, BC, 2BC, 2BC minus A square. So this is first row becomes 2BC minus A square. So this is C square, this is B square. So this is what we want. Similarly, the second, if you multiply second row BCA with C1, R2 C1, B into A minus AB, C square, A into B, AB, minus AB plus C square plus AB. So this is minus AB minus AB plus C square plus AB. AB will get cancelled, you will get C square. So next R2 C2. So B into B minus B square, C into A AC, A into C AC, minus B square plus AC plus AC, minus B square plus AC plus AC. Next one R2 C3. B into minus C minus BC, C into B plus BC, A into A plus A square, minus BC plus BC plus A square, minus BC plus A square plus BC, minus BC plus BC plus A square, minus BC plus BC plus A square. So you can see plus AB minus AB will get cancelled. So if this is 2AC minus B square, BC will get cancelled. Next, third row R3 C1. Look at this. R3 CAB into minus ACB, C into A minus AC, A into C plus AC, B into B, B square, minus AC plus AC, B square, minus AC plus AC plus B square. Now R3 C2, C into B minus BC, A into A square, B into C, BC, minus BC plus A square plus BC, minus BC plus A square plus BC. Next R3 C3, C into minus C square, AB, minus C square plus AB plus AB, minus C square plus AB plus AB. So this is multiplication, and okay, in last row AC plus AC get cancelled, BC will get cancelled. So this is 2AB. What do you get? In second row, C square. So this is 2AC minus B square. 2AC minus B square. This is A square. So this is B square, third row. This is A square. This is 2AB minus C square. This is the required answer. So this you can name it as second. So this is first proof. First and second will give us the complete proof. So we have to show that ABC, this square is equal to 2BC minus A square, and this is equal to A plus B plus C, or A cube plus B cube plus C cube minus 3ABC whole square. So from 1 and 2 is the proof. From 1 and 2, so it is proved. Hence, proved the required. From 1 and 2, it is proved. So 1 is equal to 3. So important question. This is also from the textbook. Now let us take up another important question from text. These are all long questions, important questions. Show that ABC, A square, B square, C square, A cube, B cube, C cube. So this determinant value is ABC into A minus B, B minus C, C minus A. A minus B, B minus C, C minus A అని చూపించాలి. Now let us prove it. Taking left hand side, LHS, ABC, A square, B square, C square, A cube, B cube, C cube. ABC, A square, B square, C square, A cube, B cube, C cube. Taking this one. Now from C1A, C2B, C3C, you can take common. Taking common A, B, C from C1, C2, C3 respectively. C1 నుంచి A, C2 నుంచి B, C3 నుంచి C కామన్ తీస్తే మనకు ఏమొస్తుంది? ABC కామన్ బయటకు వస్తుంది. సో C1 నుంచి A కామన్ తీస్తే ఏలో నుంచి ఏ పోతే 1, A స్క్వేర్ నుంచి ఏ తీస్తే A క్యూబ్ నుంచి తీస్తే A స్క్వేర్. ఇది కూడా 1B, B స్క్వేర్, 1C, C square will remain. So now further simplifying this, C1, I am changing C1 minus C2, and also C2, I am changing C2 minus C3. ఈ కాలం ట్రాన్స్ఫర్మేషన్ చేస్తూ ఉన్నాం. C1 లో నుంచి C2 మైనస్ చేస్తున్నాం. సో C1 మైనస్ C2 అంటే 1 minus 1 0, 1 minus 1 a minus b, a square minus b square. So 1 minus 1 0, a minus b, so third one a square minus b square. Next C2 ను కూడా చేంజ్ చేస్తున్నాం. We are changing C2 as C2 minus C3. So C2 minus C3, 1 minus 1 0, b minus c, this is b square minus c square, and third row as it is 1 c square, no change in third row. So two transformations మనం చేసాం. So further simplifying b minus c, so I am writing 0 a minus b, this is a square minus b square, a plus b, a minus b. Similarly, this is b minus c, b square minus c square can be written as b plus c and b minus c. So the last column no change. ఇక్కడ కాలం ట్రాన్స్ఫర్మేషన్ చేస్తున్నాం, నిలువు వరుసలను మారుస్తున్నాం. ఇప్పుడు ఫ్రమ్ C1 a minus b కామన్ తీస్తున్నాం. C2 0 అంటే 0లో కూడా a minus b ఉన్నట్టే, 0 into a minus b, 0 into b minus c, you can assume. So now taking common a minus b and b minus c from C1, C2 respectively. So C1 నుండి a minus b ని, C2 నుండి మనకు b minus c కామన్ తీస్తే a minus b abc, so a minus b C1 నుంచి, b minus c C2 నుంచి కామన్ తీస్తే ఇక్కడ ఫస్ట్ కాలం ఏమవుతుంది, 0 యాజ్ ఇట్ ఈస్ గా 0నే ఉంటుంది. a minus b సెకండ్ ఎలిమెంట్ కామన్ తీసాం కాబట్టి 1 అవుతుంది. ఈ థర్డ్ ఎలిమెంట్ a minus b కామన్ తీస్తే a plus b మిగులుతుంది, a plus b will remain. సిమిలర్లీ సెకండ్ కాలం 0, ఇది b minus c కామన్ తీస్తే 1 అవుతుంది. ఈ b minus c కామన్ తీస్తే ఈ థర్డ్ ఎలిమెంట్ b plus c అవుతుంది. ద C3 అనేది నో చేంజ్, 1 c square యాజ్ ఇట్ ఈస్ గా ఉంటుంది. This will be as it is, no change in C3. Now we calculate the determinant as this two numbers are 0. So the determinant, if you calculate along the first row, ఇక్కడ రెండు జీరోస్ ఉన్నాయి కాబట్టి దీని డిటర్మినెంట్ 0 into anything 0. So the determinant will be 1 into the remaining 4, 1 1, a plus b, b plus c. So the determinant we take only 1 into its cofactor. So further simplifying, ABC, A minus B and B minus C, A minus B, B minus C. So this is cross multiplication, AD minus BC, 1 into B plus C, that is B plus C, minus 1 into A plus B. So minus A minus B, minus A minus B. So now plus B minus B will get cancelled. Only C minus A will remain. So further simplifying, this is ABC, A minus B, B minus C, and C minus A. So this is the required proof RHS. So now LHS left hand side is equal to right hand side, hence proved. So these are all very important proofs in determinants, long questions, exam point of view also. These are very important proofs. So with this I conclude today's class. So prepare your notes and practice at home. And some other problems in the textbook from solved problems, examples. So you practice the solved problems from the text. So thank you for watching this video.